Welcome. It's just math, y'all. We're going to do the practice test for Unit 3. We're working on these videos. We are at problem number 24. Number 24, we're starting to kind of scramble again to see if you remember things. We did one like this already. It says determine whether the following represents a function. Give the domain and the range. For determining if something is a function or not, we are looking for a repeated x. So when we look across, we don't see any repeated yes. So x, so yes, it is a function. Now the domain is all your x members. So your domain is -5, 0, 4, and -2. And your range is all the y's. So 6, -2, 4, -2. And there we go. That's the domain and range. All right, number 5, this is composition. That is composition of a function. This is where you take one function and plug them into the other. I'm going to do a little color coordinating here. This is going to be my purple function, and this one's going to be my red function. Now the first one that's written is the p, so that's the one I'm going to start with. I'm going to start writing p. P is the square root of blank minus 1. That is what the p function is. And then in that blank, I'm going to put the f function, which is x squared plus 6. Then I'm going to simplify, and the only simplification that I can do right here is 6 minus 1. So my official answer is x squared plus 5, and that is it for p composed of f. Don't overthink this problem. All right, up next we have number 26. We have more composition. Again, we'll do it the same way. We will have a purple function, and we will have a red function. I'm picking that up just a little bit. A red function. So the first one says f composed with g, so we're going to start with the purple function. F comes first. F is the function -10 blank plus 15, and then into that we're going to put the g function, which is 3x minus 5. Then we just do whatever simplification we can do, and we're going to distribute the -10, and we get 50 plus 15. Let me check my signs. So, when you go too fast, you make mistakes. And then I have -30x plus 65, and that is my f composed with g. That's my answer for the first part. Second part, just the backwards. We'll do the reverse. We'll do the g first. The g is 3 blank minus 5. That's what the 3g function is. And in the blank, I'm going to put the f function, which is -10x plus 15. Again, I'm going to distribute, and be careful with my signs. And I think that's right, 30 and 15, and then do my signs. I get -30x plus 40. So that would be my g composed with f. Now, the domain on both of these is the standard domain. The domain of the original is the default -infinity to +infinity. And if you look at this one, it's also -infinity to +infinity. Same here, -infinity to +infinity. Domain is not an issue there. There's no fractions, there's no radicals. All right, number 27, we are trying to find an equation for the inverse function, and then we're verifying. Now, on the MyLab, this is absolutely insane on the MyLab. So please pay very close attention to this, because I do not want this to be difficult at all. So make sure you do what's here on the video and don't worry about what the MyLab says. I will change the test in the MyLab so that it matches up. So here we go. We're going to find the equation for the inverse first. And so when we do that is we do our 4-step process. And so the first 2 steps are kind of a wasted step. We're going to change the f of x to a y. And then the second step is just as weird. We switch the y and the x. So we switch the x and the y. Now that doesn't make sense, but that's why we do it. Then the third step is to solve for y, and you have to use your solving skills. So you really may need to review those skills. So the first thing I need to do to get y by itself is I got to get rid of that power. So to solve for y, I need to cube root both sides, and that's going to cancel. I'll have y plus 1 equals the cube root of x. Then Again, I'm solving for y. So to get y by itself, I just need to subtract 1 on both sides. And I get y is the cube root of x minus 1. And that's my answer. The official last step says change the y back to function notation. And so my official answer is right here. Okay, so now the second part wants you to verify that these are in fact inverses. To verify inverses, we plug one function into the other. This is kind of like fog. So technically I'm going to do f inverse composed with f. That's what this means. And I should get x. And right here I'm going to do f compose f inverse, and I should get x. So we know how to do this. It's just written differently. Let's do it. So again, we'll do a blue, a purple, and a red function. So we'll let the original be the purple, and we'll let the new one already red. So when I do both of these, I'll do them right there. So the f inverse, I'm going to do this one first. I'm going to do the cube root of blank, and it's 1. And then in the blank, I'm going to put x plus 1 cubed. Okay, so now what's supposed to happen is everything's supposed to cancel out and I'm supposed to get x. So let's simplify it. The cube and the cube roots cancel, and I have x plus 1 minus 1, and then the plus 1, and I get x. So it did verify. It did verify. All right, the second half, we'll do the same thing. This time we'll do the f first. The f is the purple function. So f is blank plus 1 cubed. That's the f function. Now in the blank, I'm going to put the thing that I calculated over here. And so now this time, when I start simplifying, the 1's cancel first, and then the power and the radical cancel next, and I'm just left with x, just like I'm supposed to. So that's how you should technically verify. The MyLab is very difficult on this, so please watch the video. All right, up next, we'll do another video. It's Just Math, y'all. See you at the next video.